Endothermic Wraps, Thermal Protective Systems. My name is Christina Larkin, and I will be one of your moderators, along with John Zalepka, who is our Training and Development Manager. We would like to take a moment to review some housekeeping items before we start. All attendees will be muted during the webinar. We will be disabling the chat feature during this session. Questions can be sent in the Q&A section at the bottom of your window. We will be gathering your questions during the webinar and will hold a question and answer discussion at the end. We will be reporting AIA credit for those of you who attend at least 75% of the live webinar. If you have an AIA number and did not give it upon registration, please send it to webinars@stifirestop.com. If you are not a member of AIA, STI will be sending certificates of attendance for you to self-report to whatever agency you wish. We will also be sending a recording to all who registered. Please allow 7 to 10 business days for the generation of certificates and recording.
Thank you, Christina. Fire-rated shaft enclosures are perhaps one of the most important features of modern high-rise construction. From fire alarm cables to fuel oil, rated enclosures are imperative to the life safety of a building's occupants. Our presenter today is Dan DeSantis, Territory Manager for STI in the New York City metropolitan area. Dan is extremely familiar with these thermal protective systems that he will tell us about today. As a former project manager for one of the largest insulation contractors in New York, he's had many years of experience installing endothermic wraps on some of the most prestigious projects in the world. And now, as a member of STI, he's brought his knowledge and experience to our team. And with that, I'll turn it over to Dan. Dan, the floor is yours.
Okay, thanks so much, John. Good morning, everyone, and thank you so much for joining us. Today, we'll be discussing the significant code changes and how that impacts design and execution of fire-rated enclosures on some of our project's most common services. We'll be diving into how passive fire protection is used to enclose mission-critical circuitry, as well as standards and solutions related to the enclosure of in-building fuel oil piping. We'll open it up for a live Q&A at the end of the presentation if any questions should arise. Today we'll be covering traditional methods of passive fire protection, such as cast-in-place concrete, fire-rated wallboard enclosures, endothermic wraps as a shaft alternative, the code language related to in-building wireless communication systems, the NFPA's contributions to the code landscape as it pertains to in-building wireless communication systems, as well as third-party test standards such as ASTM E1725. We'll then discuss the fuel oil segment as it pertains to shaft enclosure and some of the relevant codes and standards. Specific solutions will follow with discussion on UL and Intertech tested and listed systems for various real-world conditions. This graphic gives us good perspective on how thermally protective enclosures are utilized in modern construction. All of these services, from fire alarm cables to smoke extraction fans, utilize passive fire protection in order for their circuitry to remain operational under the extreme temperatures of a building fire. We'll be focusing closely on in-building wireless communication as well as mechanical fuel oil piping. But as you can see, there are many use cases for passive fire protection. Most are related to electrical circuitry. Thermally protective systems are passive in nature, meaning they live inside the building, require little or no maintenance when properly installed, should maintain their integrity for the life of the building. Traditionally, we've seen this accomplished in 3 ways. Cast-in-place concrete encasement, where the electrical pathway is completely immersed in thick concrete to prevent the heat of a building fire from interfering with the circuit's operation, as well as a fire-rated gypsum wallboard assembly, commonly referred to as a drywall shaft enclosure. Last and not least, endothermic wrap, which is a thin, lightweight material used as the shaft enclosure for protection of the building services. These wraps can provide an hourly rating of up to 2 hours, where traditional means of construction may not be possible. It's important to note that not all endothermic wraps are created equal. and it's imperative that you know the standard to which a particular material is tested before installing. Let's have a closer look at cast-in-place concrete as a protective enclosure. While concrete makes an excellent fire-rated barrier for vertical and horizontal separations like walls and floors, it lacks the versatility to provide reliable conduit enclosure due to its difficulty to visually inspect once set. And once it is set, making adds, moves, and changes is virtually impossible. This is a problem for the life cycle of a building, as upgrades and changes in technology are a way of life in modern construction. Additionally, there's no tested system for cast-in-place concrete as a thermally protective enclosure. No test standard means a wide array of possible outcomes across different manufacturers' products. This should be a concern to specifiers, as products may not perform as intended. This graph here, published by the NFPA in 2008, shows the temperature performance of cast-in-place concrete. This test was performed using an ASTM E119 time temperature curve for a typical cellulosic fire. As you'll see noted here, the unexposed side of 2-inch thick concrete reached 675 degrees Fahrenheit after just 2 hours, while 4 inches were required to maintain a passable temperature of about 325 degrees above ambient, or 400 degrees total. As we can see, cast in place is not without its limitations. Concrete encasement is difficult to inspect, impossible to re-enter without demolishing, and carries the risk of spalling before fully cured. 4-inch encasement is just not practical for most applications due to its weight and labor-intensive installation. Great for some applications like rated barriers, but for thermally protective enclosures, it's less than ideal. Drywall enclosures for fire rating of electrical circuitry is the next and most common type of thermally protective system that we'll talk about. In this plan view of what a typical gypsum shaft wall construction looks like, the configuration on one side is 2 layers of 1/2-inch or 5/8 inch sheetrock, a 2.5-inch CH stud spaced 24 inches on center, and a 1-inch core board shaft liner on the reverse. This type of construction is commonly found in MEP riser shafts, elevator shafts, stair towers, and so forth. It's a great option for enclosing large shafts or creating area separation walls in both vertical and horizontal assemblies. One of the biggest misconceptions that we see in the field is the belief that running a conduit inside the stud cavity of a rated wall will provide a rating. This simply isn't the case. In the event of a fire, the exposed side of the shaft will be sacrificed. The outer layer of gypsum will burn away early on. This is by design. The entire assembly may be rated for 2 hours, but running services within the stud cavity will not get you a rating at all. In fact, the temperatures within the stud cavity will rise within minutes, while the unexposed side may remain unaffected for considerably longer. The correct method of enclosing using drywall is to build a full depth assembly on all sides of the protected item. As you can see, these 3 emergency feeders shown in red are behind a shaft liner side of the wall. The double layer gypsum would be considered your exposed side, and 3 more sides like it must be constructed to have a full 2-hour rated assembly. Although drywall has been the go-to solution for fire-rated shaft containment, it does have its limitations. Access is the #1 issue when using drywall. This is especially important in the retrofit market segment, which we'll be discussing a little bit later. But can you frame the area that needs to be protected? Think of a busy corridor or a commercial use building, HVAC duct running next to IT wiring, next to chilled water lines. It gets extremely crowded up there. Now try to build a 4-sided drywall enclosure around a 1-inch conduit that lays on a trapeze hanger 2 inches away from a return air duct. Or maybe you have 500 linear feet of DAS cable to protect that snakes around the project. Access can be tough. especially in a city like New York where space is at a premium. Since a full depth shaft wall assembly must be built around all four sides of the protected item, you can lose finished ceiling height, and accessing the inside of the shaft for troubleshooting or upgrades can be problematic as well. The third method of protection we'll be discussing is the use of an endothermic wrap, or EWRAP for short. EWRAP is not just a material, but a tested and listed shaft enclosure system. It is a purpose-built product that was designed for the fire protection of building services. EWRAP is applied in layers corresponding to the required hourly fire resistance rating. Endothermic wrap can be used on communication hardware for arcs and DAS systems, as well as fire alarm pump circuitry, signaling equipment, panel boxes, and other mission-critical circuitry, as well as fuel oil lines. It's an extremely versatile product in its application and tested and listed by UL and Intertek for these specific purposes. More on endothermic wrap in a bit, but let's take a look at the past to see how we got here. The tragic events of 9/11/2001, where over 2,500 lives were lost on that day, among them 343 brave souls of the FDNY. If any good at all was to come from this horrific tragedy, it gave us an opportunity to improve. A few years later, in 2005, the NIST World Trade Center report was published. In it, we learned that communication was a huge issue during the events of that tragedy. The convergence of dozens of departments with no reliable way to communicate with each other once inside the building. This proved to be a contributing factor to the scale of loss of life. No evacuation order could be given, no method of distributing information in real time. 2 years later, in 2007, the National Fire Protection Association published their guide for the in-building wireless communication system. A simple solution by today's standards, but a step in the right direction. Not until 2009 did we see the first IFC revision via a new chapter, Chapter 510, which mandated new buildings must have an ERRCS system installed. Then in 2012, the NFPA launched its detailed standard, 1221, which lays out the parameters of the in-building wireless communication system. This standard is still used to this day with some minor revisions along the way. In 2018, some slight modifications to the IFC 510 to add NFPA as a reference standard for the industry. The NFPA has been instrumental in driving the code progression within in-building wireless communication systems. But who is the NFPA? Founded about 125 years ago in Boston, Massachusetts, the NFPA is an international nonprofit organization devoted to eliminating death, injury, property, and economic loss due to fire, electrical, and related hazards. As of 2020, the NFPA has over 50,000 members and 9,000 volunteers working with the organization through its 250 technical committees. The organization was originally created to bring uniformity to the fire sprinkler codes of Boston and the surrounding areas, and they currently have over 300 consensus standards in use in the United States and Canada today. References to circuit integrity and survivability are made in NFPA 72, or the National Fire Alarm and Signaling Code. The 2019 edition shown here makes mention of circuit integrity for in-building wireless voice alarm systems, systems employing relocation or partial evacuation, and of course our in-building communication systems, or ERCs. Circuit integrity refers to the operability of electrical circuits under a fire. It is a form of fire resistance rating. Circuits integrity is achieved via passive fire protection means, which are subject to stringent listing and approval for use and compliance. The National Fire Protection Association dictates the parameters that must be met when installing your in-building wireless communication system. Among these is 95% radio coverage of every floor of your building is required under this code. Under related codes such as National Fire Alarm and Signaling Code, 90% of these floors' general building area must be covered with a radio signal, and as much as 99% of the floor's area coverage in critical areas such as high traffic or paths of egress, identified by your AHJ. Let's talk a little bit about wireless coverage. In the same way we need a router at home for our Wi-Fi internet signal to cover our houses, in-building wireless communication systems rely on strategically placed emanators and repeaters in order to cover a required square footage of a large building. NFPA 1221 stipulates that no less than 95% of the building's general square footage must be covered with such a signal. No signal means no communication, and in the event of a fire, that could translate to loss of life. The National Fire Alarm and Signaling Code has a slightly different standard. They require that 90% of general building square footage must be covered and 99% of critical areas such as fire pump rooms. Paths of egress and stair towers must also be covered. It's important to consult with your AHJ on the project to gain a clearer perspective on what's required. NFPA 1221 is a very broad standard that covers everything from hardware coverage to coverage requirements for your in-building wireless communication systems. But what we'll be focusing on next is the rated enclosure aspect of the code. There's two specific mentions in the standard regarding rated enclosures. Both can be found in Chapter 9. The first reads, backbone cables shall be routed through an enclosure that matches the building's fire rating. Notice that no guidance is given on the type of shaft enclosure that's required, but only that it matches the building's fire rating. The building's fire rating is most often defaulted to 2 hours in most high-rise construction applications, but this could vary from job to job and can range from 1 to 2 hours. The standard's next mention of rated enclosures is in the following chapter. The connection between the backbone cables and the antenna cable shall be made within an enclosure that matches the building's rating. This refers to the connection between the vertical backbone cable and the horizontal antenna offsets, which should be made inside an enclosure that matches the building's rating, typically 2 hours in most cases. Requirements for in-building emergency radio communication systems were first introduced into the International Fire Code in 2009 edition of Section 510. Buildings that cannot support the required level of radio coverage shall be equipped with an indoor distributed antenna system, or DAS, with FCC certified signal boosters or a system that is otherwise approved. The IFC also added a requirement for existing buildings that did not already have an approved emergency radio communication system to meet the same requirements in effect for new buildings within a time frame established by the AHJ. The International Fire Code stipulates 95% general building coverage for public safety. This is significant due to what's known as the creation of the retrofit market. Older buildings requiring a new ERC system has much more unique challenges from an execution standpoint. Existing shafts and rated pathways may not be an option without invasive demolition or extensive review of the surrounding construction. We must often look to alternative shaft enclosure methods like endothermic wrap for these applications due to their complexity and access issues. Under IFC 510, here's what we can expect the world to look like. A retrofit system being deployed in new and existing buildings alike. You'll see some examples of the hardware involved with these systems: vertical donor antennas with strategically placed repeaters to ensure the proper levels of coverage. In these hypothetical examples, both vertical and horizontal offsets would need to meet level 2 survivability for their pathways. This means the fire-resisted enclosures matching the rating of the building, which in most cases is 2 hours. So how do we know if a material is suitable for use as a fire-rated enclosure? Well, we burn it. Using the ASTM E1725 standard, a full-scale test is conducted in a burn lab. The temperature curve you see here is what's called the ASTM E119 temperature curve. This simulates real-world building fire conditions. The same time temperature curve is used for through penetration fire stopping, joint construction fire stopping, as well as curtain wall fire stopping. They even use this time temperature curve to evaluate the barriers themselves, to determine if gypsum wallboard assemblies can carry a fire resistance rating, for instance. This curve helps to achieve a consistent fire rating that serves as a baseline for all systems. Having a consistent test acts as a yardstick to measure against for all systems across all manufacturers. During this test, thermal sensors are placed inside of an enclosure on a bare copper conduit. In order to pass this standard, the average temperature rise across all sensors may not exceed 325 degrees above ambient, or about 400 degrees total. When you use an endothermic wrap tested to ASTM E1725, you're using a product that's been third-party tested with these strict parameters by an independent lab. Let's take a look at some case studies by region to see how the code requirements compare by city, starting with New York. Under the 2014 NYC Building Code, a new high-rise building, one that is 75 feet or taller, in any of the 5 boroughs, must include provisions for FDNY in-building wireless communication systems, known in New York as an ARC system, or auxiliary radio communications. Older buildings undergoing renovation or changes in occupancy class may also have to meet the same requirements. The specialized hardware required for an ARC system provide on-site command and control throughout the building. ARCs provide clear radio communication from the basement to the top floor of the building, and some areas outside, using existing FDNY radios. Only the FDNY is permitted to operate the ARC's controls. The auxiliary radio communication system uses a building-specific antenna combined with a low-powered transmitter and receiver. An engineer custom designs each antenna system to make sure that it's balanced with consistent and adequate radio coverage. Moving north to Boston, found in the 8th edition of the Massachusetts Building Code, adopted in 2011, emergency responder radio systems are required in all new building construction. These requirements can be found in Chapter 9 of the Code Requirement of Massachusetts, or CMR for short. There was a major revision to the Chapter 780 of the CMR on April 11, 2014. This code section lays out the parameters for hardware coverage and survivability requirements of the hardware within. Beginning with the 2010 Philadelphia Code cycle, all new buildings in the city of Philadelphia are required to have an emergency responder radio coverage system. According to Pennsylvania building codes, all new buildings which are less than 75 feet above or less than 20 feet below the lowest point of fire department access are not required to have ERRCS. ERRCS systems in Philadelphia must align with NFPA 72, meaning that all systems must be compatible with VHF handheld radio communication devices. Frequencies should be between 700 and 800 megahertz public safety channels. Antennas should be bidirectional. Backup power is required for the system. All systems must meet FCC requirements. ERRCS systems for Pennsylvania must have the application, installation, location, inspection, testing, and maintenance performed by a licensed professional. Although the three cases discussed have their subtle differences, the commonality is a requirement to at least some extent for the deployment of an ERRCS system in both new and existing construction. When it's been determined that an existing building is required to have an ERRCS installed, the challenges can be unique. Perhaps the upgrade is occurring in an existing hospital or a fully occupied dormitory. Those cases can be challenging when it comes to achieving circuit integrity. Retrofits have surprises. Countless changes are made to the IT and security systems over the years, leaving little space for new pathways. Existing shafts may not be accessible without invasive demolition. Endothermic wrap is a silent installation. No power tools are required. This is ideal for a building that's occupied, such as a hospital. And it means less disruption to patient care and overnight sealing permits with work that won't disrupt the occupants. EWRAP is also the lowest profile solution for circuit integrity. At just half an inch thick per layer, space becomes less of an issue and your survivability requirements are met without sacrificing finished ceiling height. Structures like parking garages and stadiums also have their circuit integrity needs. Traditional means of shaft enclosure may not fit the aesthetic of a particular building, especially those with an open ceiling or industrial design concept. Endothermic wrap, as well as providing the required 2-hour rated enclosure for critical path services, blends into the surrounding mechanicals as well. It can be jacketed with a colored PVC to fit the desired aesthetic of the project as well. Here's a little summary of what we've learned about endothermic wrap so far. It's tested to the industry standard for circuit integrity in ASTM E1725. Third-party testing from UL and Intertech labs with unique listing numbers for various applications. The product is highly flexible for use in small diameter conduit or threaded rod supports. At just half an inch thick per layer, it's thin. And just 1.3 pounds per square foot, it's the lightest weight solution on the market today. No additional support for weight is required. And of course, EWRAP gives the design professional a clean aesthetic for exposed ceiling and open concept designs. The image on the right is pulled from our Intertech listing for a 2-hour rated enclosure around EMT. We'll be breaking that down a little bit further in just a few minutes, but this serves as the basis of the design for a lot of our electrical circuitry solutions. So how does a thin and lightweight material have the ability to protect circuitry under extreme conditions of a building fire? Well, as the name implies, this class of material is endothermic in nature, meaning it absorbs heat to initiate a reaction. EWRAP contains chemically bound H2O molecules which absorb energy in a slow and predictable way. The energy is diverted away from the circuitry via steam, keeping the temperatures inside at a reliable level and maintain the integrity of the pathway. Endothermic wrap is applied in layers corresponding to the required fire resistance rating of the protected item. In the image shown here, 4 layers were required to protect this item for 2 hours for a 2-hour fire resistance rating. When we're talking about circuit integrity and survivability requirements, it's not just the conduit that requires protection. Hardware housed in steel junction boxes, such as repeater cabinets or switches, must also be protected as part of the system. Having a fully encapsulated system is imperative to the performance of an ERRCS under fire conditions. It's only as strong as its weakest link, which is why we provide systems for various size boxes in different orientations. On the right, we have a typical steel box. This could be part of a DAS. This could be a part of an emergency DAS system oriented against the CMU block wall. Using endothermic wrap, this box is now protected for a 2-hour fire resistance rating. You'll notice in this orientation against the CMU wall, the endothermic wrap is fastened directly to the CMU substrate. Since the box is mounted directly to the wall, this saves space on the project without sacrificing any of the circuit integrity requirements. It's not just DAS hardware that might require protection. Maybe it's a utility panel for a backup generator or a med gas valve box. Either way, using endothermic wrap is a tested and purpose-built solution for the protection of these items that will meet the performance requirements of the building code for your region. The sketch shown on the right shows both section and elevation views of a typical panel box recessed into a 2-hour rated gypsum wallboard assembly. Endothermic wrap turns this into a 2-hour rated box and adds very little weight to the overall design. Endothermic wrap is UL listed for 1 and 2 hour applications. At just half an inch thick, it doesn't require any additional accommodations for space, with generally only one layer required for these conditions. Here on the right, we have a real-world example of a recessed panel box. As you can see, the material fits neatly within the stud cavity on all sides of the box and is now 1 or 2 hour rated and just takes a few minutes to install. We know how effective endothermic wrap can be for the circuit integrity segment, but did you know the same product is tested and listed for the dedicated shaft enclosure of fuel oil piping? In-building fuel oil piping has become increasingly prevalent due to its use in emergency backup generators. Once thought to be limited to hospitals and other public facilities are now found in many high-end residential towers, as well as commercial settings around the country. Fuel oil presents a unique challenge, as it is a combustible liquid that needs to be protected under the threat of fire. Let's take a look now at the code requirements for fuel oil and how it should be protected. In the IBC, Section 403 of the code requires that fuel oil lines supplying a generator set inside of the building shall be separate from areas of the building other than the room that the generator is located in. IBC Section 2702 reads as follows. Fuel oil lines supplying a generator set inside of a high-rise building shall be separated from the areas of the building via an assembly that is fire resistance rating of not less than 2 hours. Further breakdown of this code reveals that any fuel oil piping not located within the same room as the generator or storage tanks must be protected with a 2-hour minimum fire resistance rated assembly. Furthermore, codes like the New York City Building Code clearly stipulate that fuel oil must be in a dedicated shaft or one that is not shared with any other services. This can cause some design complications because large MEP riser shafts in the core of the building would not be considered dedicated. Therefore, a shaft within a shaft would be required if those risers are used. Let's take a closer look at the New York City Building Code on fuel oil line. Under the 2014 NYC Mechanical Code, dedicated shafts for fuel oil should not be penetrated by or shared with other piping and ductwork. Completely dedicated shafts are required. Chapter 13 speaks about the fuel oil piping requirements and states that fuel oil return and vent piping enclosed in a shaft of 4-inch thick concrete or an enclosure that matches the building's fire rating. In most cases, this will be 2-hour enclosure, but your rating may vary. Please consult with the AHJ of your project for the exact requirement. Here's the code language for horizontal offsets from the 2014 Mechanical Code of New York City. Horizontal offsets shall be enclosed in construction having a 2-hour fire resistance rating. In certain areas of the city which are prone to flooding, they may require emergency generators to be located on the roof of the building. This would produce a lot more horizontal offsets as piping is run from the subcellar storage tanks to the rooftop generators. Where piping turns out of vertical shafts to vertical shaft would be considered a horizontal offset. The use of endothermic wrap can be used in conjunction with both CMU and gypsum wallboard assemblies. We'll be breaking that down a little bit further in a bit. We currently protect fuel oil piping in a number of different ways. Gypsum wallboard assemblies are great for large MEP shafts, but since fuel oil require dedicated shafts, space and access can become an issue. Cast in place encasement, much like with electrical circuitry, is an acceptable method but seldom used due to its weight and inability to re-enter once cured. CMU shafts are commonly used for long vertical runs between floors because they're relatively inexpensive and provide reliable protection. But that's not really practical for horizontal offsets or for retrofit applications. Before we move on to specific solutions, let's recap. Fuel oil means dedicated shaft enclosure. Existing MEP risers still require a shaft within a shaft for full compliance. If space and cost are important considerations, endothermic wrap may be the correct solution for this aspect of your job. Also keep in mind that E-wrap can be used with conjunction of other methods of enclosure, such as CMU and drywall. In these cases where fuel oil piping exits the traditional shaft enclosure, the penetration would be fire stopped as a typical through penetration, and endothermic wrap would be butted against the substrate. As we can see here on a large project completed in New York City where 16-inch wide spill duct enclosure housing several fuel oil lines was enclosed using endothermic wrap. The application blends seamlessly to the surrounding construction and code requirements for fire resistance are met. Why use an endothermic wrap for fuel oil line? Well, the code tells us that piping, both vertical and horizontal, must be contained to dedicated shafts. These can take up space that could be better served on your project. They're often costly to build if cast in place or CMU are involved. Testing for single and double containment fuel oil systems has been conducted in third-party labs like UL and Intertech. Endothermic wrap is only 1/2 an inch thick per layer. This saves space for the shaft within a shaft applications. No additional weight or reinforcement is needed to accommodate the weight of E-wrap. It is a standalone shaft alternative that fits existing hangers and standoffs used by pipe fitters around the country. So what exactly does third-party testing mean in the case of E-wrap for fuel oil line? We tested the product to the industry standard, UL 1489. This is a burn test conducted in UL's lab. Much like the test for electrical circuitry, there are strict pass-fail criteria. In order to achieve UL 1489, the average temperature rise along a protected fuel oil pipe may not exceed 250 degrees Fahrenheit above ambient temperature, and no one sensor may exceed 325 degrees above ambient to achieve a passing result. E-wrap is also recognized by the New York City Department of Buildings Office of Technical Certification and Research as an approved method of fire resistance enclosure for fuel oil lines. This 8-inch double containment fuel oil line is a good example of a use case where a finished ceiling height was a major consideration. With traditional methods of enclosure, you would lose considerable height. In this case, the piping is isolated and protected without the need for drywall. It's a great solution for rooms like this crowded MER. Next, we'll be speaking about some of the proprietary testing and listed systems for STI's EWRAP. We'll cover some of the specific requirements for installation, as well as some of the project's specific conditions commonly encountered that warranted the use of engineering judgments. We'll take a closer look at some of the Intertech and UL listings for endothermic wrap, as well as a closer breakdown of junction boxes and through penetrations, like those of unlike shaft enclosures. This particular test system was tested by Intertech, listing number STI AF12001. This is an all-encompassing conduit system for the 2-hour F-rated protection of a conduit. This system allows for 2 different methods of installation. The telescopic method, where layers are offset by 2 inches and overlapped horizontally as layers are installed, as well as the butted seam method, where all layers are applied in 24-inch wide sections and butted against the next. When a butted seam method is used, a bead of LCI intumescent sealant is required on the outermost seam, where no additional sealant is required for the telescopic method. Either installation is completely acceptable as far as this listing is concerned. It's just a matter of installer preference. Regardless of which method is used, we allow for the use of 1/2-inch banding coil or 16-gauge tie wire on the outermost layer to fasten in place. Banding coil provides a cleaner aesthetic, whereas tie wire may be a quicker installation, but both are accepted under this Intertech listing. On the fuel oil side, UL listing numbers FP3 and FP4 are STI's proprietary listing for fuel oil line enclosure. FP3 is used for single containment fuel oil line, whereas FP4 is used for double containment. When properly installed, these systems provide a standalone 2-hour rated enclosure under the UL 1489 test standard. Like the previous Intertech system, the material is applied in layers corresponding to the required hourly rating. On this 8-inch diameter fuel oil line shown, 4 layers were being installed telescopically to achieve a 2-hour rated enclosure. As mentioned, EWRAP is applied in layers corresponding to the desired hourly rating. For smaller conduits, size 4 inches and down, 5 layers are required for a 2-hour rating. Conduit greater than 4 inches in diameter only require 4 layers to achieve a 2-hour rated fire resistance rating. Here is an image showing the finished installation on a fuel oil line. In this case, the contractor opted for the use of 16-gauge tie wire on the outermost layer, but 1/2-inch banding coil is also acceptable in this scenario. Regardless of which method is used, banding coil is always only required on the outermost layer. Here we see STI's proprietary listing with UL, WL7307. This is for a recessed steel box, such as an electrical panel or med gas valve box. 1 and 2 hour F ratings are supported with this system with just a single layer of 1/2-inch EWRAP. This system only applies to boxes which are recessed in 1 or 2 hour rated gypsum wallboard assemblies and provides a lightweight solution for rating boxes that's easy to install and doesn't require any special tools to complete. To maintain the rating of a conduit or fuel oil line through an opening in a cast-in-place floor or a CMU wall, CAJ 5437 was designed to accommodate through penetration fire stopping of wrapped pipe and conduit. a simple LCI and mineral wool solution to maintain the integrity of your rated barriers when using E-Wrap. In this case, an 8-inch double containment fuel oil line exits the CMU shaft directly beneath the floor slab. Using this typical detail, we are able to support the use of E-Wrap transitions from shafts of unlike materials. This is also a great system to maintain a continuity of protection through cast-in-place walls as well. We realize that every project presents its own unique set of conditions and challenges, which is why we have the best team of fire protection engineers in the country ready to field your project-specific requests. Conditions like wall-mounted repeater cabinets, or maybe it's a common enclosure of multiple conduits that need protection, or even a unique hanger or support piece that needs to be protected as part of a system. Whatever the condition may be, we're capable of producing the right solution for your project. The average turnaround time for engineering judgments with E-Wrap is 24 hours or less. Engineering judgments are always designed by and written by a professional fire protection engineer and never by salespeople. Here's a list of just some of the atypical...
Sorry, I didn't catch that.
Sorry, Siri. Here's a list of just some of the atypical conditions that we have encountered in the past. The sketch on the right shows a typical trapeze hanger with 4 conduits that can be protected together in what's known as the common enclosure. Below that is a section view of 3 conduits ran tight against the concrete floor. This is a low-profile design that is popular in the retrofit market due to its space efficiency. These conduits are protected with what's known as the clamshell method. Layers are half-mooned and mechanically fastened to the deck instead of wrapped around the full circumference. This is great for cast-in-place walls and floors, since shorter standoffs can be used to protect finished ceiling height. This concludes the AIA portion of our presentation, but we'd now like to show you a few areas of interest before we get to your questions. For product estimation on our website, we have an excellent tool that calculates the exact amount of E-Wrap that you'll need. You just fill in the parameters of your project on the left-hand column, and below a bill of materials will appear with quantities of all the materials required. Here's a list of some of the services that we provide to our partners absolutely free. Like discussed, 24 hours or less turnaround time on engineering judgments, custom fire shop training in your office or on your job site, live chat with a fire protection engineer between the hours of 7 a.m. and 7 p.m. Eastern, documentation for your AHJs, which can include submittals or UL details, technical inquiries and lead letters for your project's leads requirements, and of course, BIM modeling objects to place right in from our database of BIM objects directly into your model. STI's System Search and Submittal Builder for finding Firestop systems on your phone, tablet, or on the web, streamline Firestop system submittal packages, integrate user documents and company logos directly onto your submittals, and embed engineering judgment documents. Okay, I'm going to turn it over to John so he can discuss a little bit more about Access STI, and then we'll take some of your questions.
Appreciate that, Dan. Thank you very much. Everyone, as you can see, we have a QR code up on the screen. I recommend, if you can, hit that with your phone. That'll take you right over to Access STI. This is where you can create an account if you don't already have one. What's beneficial about doing this is that any work that you do within System Search and Submittal Builder or any engineering details that you need will all be stored within your account. This is also where you will be able to find the recording that Christina is going to be sending out to you within the next 7 to 10 business days. Dan, if you could go to the next slide, please. These are some of the other trainings and webinar recordings that we've had done in the past, and they're up on Firestop University. So if you are here for some of those continuing education credits, you can see up on the screen there some of the courses that we have where you can get that knowledge and get those credits. Or if you're just a fire stop nerd like myself, you can head on over there and bang away. We have hours and hours worth of information. And Dan, I just want to say, Siri can be very temperamental. So I really like how you kind of flowed with that. Alexa popped up to me the other day. She's probably going to do it to me right now since I just said her name. But well done flowing with that.
She's always listening.
She is. If you want to pop to that next screen so we can tell everybody about the feedback. So here you can see another QR code. We love those. This will take you over to LinkedIn. If you don't mind, hit that with your phone. Give Dan some feedback. Let him know how he did, how we can improve if you really liked it. Let him know that as well. It's always nice to get some positive feedback. And we're going to be giving away a couple of bags. So we have some prizes. So feel free to go over there. If you leave some feedback, you'll be entered for a chance to win one of these great prizes up there. So Christina, are you ready to get us into some questions here?
Yeah, I'm ready.
All right, take it away.
So the first question is that we have is, have you had a building inspector require endothermic wrap or some sort of fire protection on the hangers suspending the conduits you are trying to protect from fire?
The answer is yes. We have had it required in the past, absolutely. And if that's the case, then we can put together some custom specific engineering judgments for the type of hanger, whether it's a trapeze hanger or if it's like a single axis clevis hanger or something like that. Either way, yes, we've seen the requirement out there, and it makes sense because if you lose those hangers under the conditions of a fire, then you pretty much lose whatever it's attached to. So we understand the logic, and if that's the case, then we are more than happy to write you an engineering judgment for it.
All right, next question here. Some designers out there are referencing fire-rated cables as opposed to an endothermic wrap or something that needs to go in a rated enclosure. Can you comment on any of those differences that maybe you've seen out there, Dan?
We've seen some of that pop up here and there. We've seen some of the fire-rated cables come up. I think for a lot of people, the cost can be prohibitive in most cases. If you have, several thousand feet of cable, it can really add up on you. And just keep in mind, if you're using those cables, you still have to use those rated cables in your vertical and horizontal shafts where you might not need to. So having the flexibility to use endothermic wrap in conjunction with your existing construction. So maybe you just need it on this 100 feet of horizontal offset because your verticals are covered, can save you a lot of money on a project.
Sure, and I think that's critical, like you said, in retrofit applications where some of these cables may already be hooked up or probably are hooked up to something, so you don't want to be disconnecting workstations and things like that. So there's a place for all the different types of construction, and this is just another option for you. Great question, Mike. Thanks.
Next question we have, who are the licensed individuals required for the ERRCS?
So in this, I think we're talking about the city of Philadelphia. There's, I guess we're talking about New York too. So in New York has a list a list of contractors who meet the FDNY certificate of fitness for designing and installing the ARC systems for the city of New York. There's many of them, a couple dozen of those contractors and designers that exist in New York. I believe a similar situation exists in Philadelphia where they have a bunch of vetted contractors and designers who have been vetted by the city of Philadelphia in some way, like in New York, but those lists are publicly available. I would say if you're really interested in knowing that, you probably want to contact your local fire department.
All right, Dan, would you need to be certified to install EWRAP in hospitals, or can that be done in-house?
So certified is a broad question. We would certify you to a certain extent to install the product, meaning that we would put you through a training session in the field or maybe even virtually via Zoom in order to get your certificate from us that says that you're qualified to install the product, similar to what we would do for our fire stop installations. But as far as like a third party certification to install in hospitals, I'm not sure that exists. I don't believe it does. The only requirement in that case would be from the manufacturer. So that's us.
Yeah, Dan, I think I'll just jump on that. I've seen it in the past where, the AA, the authorizing agency, or AHJ may require some type of certification or some type of manufacturer training. That could also very well be written in the spec by your architects, engineers, things like that. So always check your specs and, double check with the manufacturer for the most up-to-date training. So, great question. Next one, Christina, you got that?
Yeah. Are the bands that are used to hold the wrap in place a 2-hour fire rated product as well?
So they are steel bands, so either 16 gauge tie wire or 1/2 inch wide stainless steel banding coil. Those products are not particularly tested or listed to any standard other than they're part of this system. So like when we talk about EWRAP as being a system, it's not just the product itself, it's the entire system. So that includes the banding and closures. So they're not any special type of banding, only that it's 16 gauge if you're using tie wire, or if it's 1/2 inch steel if you're using banding coil.
All right. Can endothermic wraps be used for medical gas piping passing through hazardous storage and equipment areas, as well as vertical riser applications?
Medical gas as in like O2, I'm not 100% sure about that. We have testing for all sorts of liquid combustible, like such as fuel oil line. That kind of falls under the gas side of it, and I'm not 100% sure if we support that, to be quite honest with you. I'm leaning towards no.
But Enrique, if that's something that you have a specific instance of, if you wanted to kind of send that in, you can go to our website, stifirestop.com. You can chat with an engineer and maybe can get a better answer, or maybe we might test it in the future. All right. Next one, Christina.
Can EWRAP be used to protect ductwork in a place of a fire damper?
The answer is no. We don't have any tested or listed systems for ductwork, and certainly not for the replacement of a fire smoke damper. So the answer would be no. And I don't think that the product would be best suited for something like that. It's just not what it's made for. But maybe something to look at in the future if that's becomes something to look at.
We had a lot of questions come up about damage, Dan, or even, when someone has to get in to repair a line or get in there to access a panel or something like that. What is the method of repair, if you will?
So for the most part, since this is fastened with stainless steel banding coil or tie wire on the outermost layer, the other layers are just taped in place. So it becomes really easy to access. So if you cut off the outer banding coil, right, that will have to be replaced. You're not going to be able to replace that banding coil on the outside, but the material itself should be salvageable. If you just cut along the tape lines and remove it, you can put the material right back on and then reband it when you're done. So you're not going to lose any of the actual material. That's the expensive part. The banding coil is pretty inexpensive aspect of the system. So you will have to cut that off and the tape. But once you tape everything back up and band it, you're good to go. So you're not going to lose the material itself if you're careful with it. If you cause a lot of damage to it, you might have to replace a layer here or there. Maybe the outermost layer might have to be replaced. But for the most part, we're seeing guys who have to troubleshoot DAS and ERC systems be able to just re-enter that product pretty easily without any damage, and they're good to go.
Looks like we have time for one more. Christina, you want to take that last one?
Yeah. Does the wrap provide the same F&T ratings?
We have T ratings available for, yes. So you can use EWRAP to provide T ratings to floor penetrations. So the top side of your floor penetrations where your T rating requirements are. We have 1 and 2 hour T rating systems available with EWRAP. So that is a supported method for T rating. So to answer the question, absolutely.
All right, appreciate that, Dan. All right, we're right up against 11 o'clock. Everyone whose questions didn't get answered, we're going to get those out to the field to get back to you. But that's all the time we have for right now. Dan, thank you very much for doing all this great work and preparing. Christina, thank you very much. You want to just tell everybody one more time about the certificates and the recording?
Yeah, just so everyone's aware, we will be reporting AIA credit for those of you who attended at least 75% of the live webinar. If you're not a member of AIA, we will be sending certificates of attendance to everyone on the call, as well as a recording. Just please allow 7 to 10 business days for the generation of certificates and recording.
Oh, hey, Dan, we have one more slide, don't we?
Boom.
Oh, there it is. Okay, so everybody, we do have some other webinars that are in the works, one for engineering judgments. We have another one also that we're working on for the International Building Code, the 2021 updates and things like that. They will be coming along very shortly. But in the meantime, this is what we have scheduled for our Fit Level 2. This is typically a 2-day session at our corporate headquarters, but due to the pandemic, we're doing everything virtually. So this will actually be done over 2 days, 2 4-hour days. So if you are an architect and need those credits, or you're with Bixie, we have those available for you. And also, if you're interested in being a trainer for STI, this is where the Train the Trainer program begins. So feel free to register for that. And we look forward to seeing you on a training in the future. Thanks again, everyone. Dan, take care, my friend.
Thank